Welcome to this video. We will show how the KirLab HIL can be used to simulate a buck converter controlled by an STM32 evaluation board. The HIL device will run a buck model, generating analog signals such as output voltage and output current, and reading a digital input that will control the switch. The STM32 controller will run a PID loop to regulate the output voltage, generating a 200 kHz PWM signal. We will create the buck model from scratch. Let's start by opening the KirLab Studio application and creating a new project. In it, let's right-click on the Circuits folder and create a new one. We will find the library on the top left of the view. Let's add the basic components of a buck converter without modifying default values, and connect them. We will also add the input and output components from the library, with a digital input for the PWM and two analog outputs for the current and voltage. We will adjust the gains for the analog outputs to match the controller ADC. And finally, let's add some labels to the circuit nodes. We can verify that the circuit has no errors, and build it. The build process may take a few minutes. Now that the circuit has been successfully built, we can create a monitor screen to easily interact with it. Go to Monitors, right-click and create a new one. In it, we will add a plot for the output voltage, and sliders to modify circuit parameters as the input voltage. We can also modify the inductance, capacitance and resistance as we want. Let's also create a log setup, so we can use the scope functionality. Go to Log Setups, create a new one and select the output voltage, diode voltage and inductor current signals. We are now ready to load the model into the HIL device. Let's connect the adapter board and the USB cable. The device should quickly appear on the top left side of the application. We can load the project in the device and start it. The output voltage is 0 as the controller is not yet working. Let's open the STM32 IDE and load the controller application. You can find it in our public GitHub repository. We can see that the controller is already regulating the voltage at the desired set point of 3.3 volts from a 6 volts input. In the terminal window, the controller is printing its measurements. We can now play with the input voltage. As a principle of operation, the output voltage will match the 3.3 volt set point when the input voltage is higher or equal. If we go to the Scope tab, we can choose the time window and get a high-resolution capture of the model signals to analyze the system behavior. We can, for instance, measure the PWM period and verify that it corresponds to 200 kHz, and accommodate measurements for further analysis. Thanks for watching this video. If you found it interesting, hit the like button and subscribe. You can find more information at KirLab.com.